So in general, you're giving a logarithmic equation. We've got log base b of a is equal to x. And yesterday we found out that it's just another way of saying an exponential function, where we've got a base, we've got an exponent, and we've got an argument, or the output of the exponential equation. So base to the exponent power is equal to the argument. And if we wanted to solve for x, well, that means that we need to get the x down here and set the log of the output divided by the log of the base. And that's the goal, is to solve for the unknown exponent. So in general, you're going to be given something like this, log base b of a. So if you want to do the quick little magic trick, bibbity bobbity boop, you could do this by evaluating the log as log of the argument over the log of the base every single time. So this is the magic trick of evaluating log. But I'd rather you understand that it is an exponential equation in disguise. And in the next video, we're gonna be figuring out what this log does, actually. But for now, just pretend I'm a wizard. It's a magic trick. It's amazing. All right, so let's do some problems. Okay, so I'm going to show you, we're gonna evaluate logs. We're gonna round to the nearest 5 decimal places if need be. Okay, so for instance, let's take a look at number 1, log base 5 of 25. So I'm not gonna label out base, exponent, and argument, but I just want you to, I'm going to point at it rather. So remember that there's an equal sign and we don't know what this is. So we have a base, we don't know the exponent, but we know the argument. So we can rewrite the problem as 5 to the unknown power is equal to 25. So this is a pretty simple enough problem. So what we can do is our magic trick, which is the log of the argument divided by the log of the base, so log of 25, close the parentheses, divided by log of 5, and you will get 2. So that means log base 5 of 25 is 2. Okay? Let's take a look at number 2. Log base 3 of 81. And we don't know what it's equal to, which tells me that we don't know the exponent yet again. So you can do the little trick, log of the argument divided by log of the base. I'm just going to do it the long way every single time, just so everybody gets familiar with both, because this is not going to be the only test we have on logarithms. I'll let you know when the test is, but it's not tomorrow. Okay, so we've got log base 3 of 81 is unknown. So that means that we can write this as 3 to the unknown power, let's just call it x, just for the sake of argument. 3 to the x power is equal to 81. Well, do I have a little magic trick? Oh, of course I've got a magic trick. It's the most amazing magic trick ever. So we've got the exponent is equal to the log of the output, or the log of the argument, divided by the log of the base. So that's x is equal to log of 81 divided by log of 3. You plug it in the calculator, close the parentheses on the 81, and you should get 4. So because that means 3 to the 4th power is 81, and we win. Okay, so let's take a look over here. Log base 6 of 36. So we don't know the exponent, so we've got 6 to the x power is equal to 36. Now, I want to solve for the unknown x by doing x is equal to the log of 36 divided by the log of 6. I would plug that into the calculator and I would get 2. Okay, so then log base 6 of 36 is 2, because 6 squared is equal to 36. Okay, so the only reason I'm not pulling up the calculator is just for time, but if you have a calculator on you, that's what you would be doing. Okay, so this one, again, I picked a big number, so I am going to use my calculator. Hopefully it's a whole number. Okay, here we go. So we've got log base 9 of log base 9 of 6,561 is unknown. But that means that we've got 9 to an unknown power is equal to 6,561. Well, what's my little magic trick? Remember, it's the log of the argument, or the output of the exponential function, 6,561, divided by the log of 9. Okay? Let me just make these parentheses a little bit less confusing. So then I'm going to plug that into my calculator just because I'm in the same boat as you guys. So we've got log of 6,561, close the parentheses, divided by log of 9. Am I getting the same numbers? Log of 6,561 divided by log of 9, close the parentheses, and I should get 4. And confirming that, 9 to the 4th power is 6,561. So I do the gymnastics, I do my little magic trick, and I get x is equal to 4 because 9 to the 4th power is 6,561. Okay. All right. See if you can do these next problems independently. Oh, sorry. So it's a little bit different. So I'll walk you through the first one, and then I'll see if you can do this problem independently. All right, so remember what the base is. The base is 49. The exponent is unknown. So we've got 49 to the unknown exponent is equal to 7. Well, 49 to the first power is 49. 49 squared is way bigger than 49. So the only thing I can think of is that this exponent has to be less than 1. But I know better. I just had a test on nth roots and nth roots and rational exponents. So let's spoil it. 49 and 7. The relationship between 49 and 7 is that 7 squared is 49, and therefore the square root of 49 is 7. So we need to figure out what the exponent is that results in the square root, even though you already know it. I'm sure you do. So let's do this. X is equal to the log of 7, magic trick, divided by the log of 49. And I would get, bibbidi-bobbidi-boo, log of 7 divided by log of 49. That'd be 0.5. Hey, wait a minute, that sounds familiar. So that means 49 to the 1/2 power is 7. And we remember that because the square root as an exponent can be rewritten as the 1/2 power. If it ends in a decimal like 0.5, go for it. You can write log base 49 of 7 is 0.5. I'm not going to stop you. Okay? But if the decimal repeats, please indicate that it repeats. Or if you really want to show off, write it as a fraction. Okay. So log base 27 of 9. Well, 27 to what power is 9? Well, gotta go with my gut on this one. It's going to be less than 1. So I've got x is equal to the log of 9 divided by the log of 27. And I'm going to plug that into the calculator. Log of 9 divided by log of 27. And I'm going to get, I put an x, I put in log of 9 divided by log of 27 is going to be 0.6 repeating. I know that 7 is not, it's just rounded up from the previous 6s, but it's 0.6 repeating. So what that means is, as a fraction, we know what 0.6 repeating is. It's 2/3. So 27 to the 2/3 power is 9, because the cube root of 27 is 3, and then 3 squared is 9. Okay? If it ends in a decimal, you can write it as 0.6 repeating, but please indicate that it is repeating. But I would prefer a fraction if you can. Okay? That'll strengthen your knowledge really quick. So let's take a look at this. Log base 2 of 1/16. Well, once again, the exponent is unknown. So we've got 2 to the x power is equal to 1/16. Well, I'm combining the knowledge I had from 2 tests ago to now, but I get this gut feeling that there's something about the relationship between 2 and 16 and having a 1 over it. The exponent's going to be negative. Ah, okay, cool. So anyway, let's just confirm it with the calculator. So we take the log of the output, 1/16, divided by the log of 2, and we close the parentheses. So let's do that. So log of 1/16, close the parentheses, divided by log of 2. -4. Ah, that makes so much sense. So x is equal to -4. Therefore, log base 2 of 1/16 is -4, because 2 to the -4th power is 1/2 to the 4th power, which is 1/16. Okay? All right, let's see if you can do number 8. Log base 5 of 1/125. Okay, so you should pause the video if you want to do this, because right now we don't know the exponent. 5 to the x power is 1/125. So therefore, we can do our little magic trick and say log of 1/125 divided by the log of 5. We're going to plug that in our calculator. Log of 1/125. Okay, I'm going to keep it right there. Divided by the log of 5. And I'm going to get -3 because 5 to the -3rd power is 1/125. 5 to the -3rd power becomes 1/5 to the 3rd, or 1/125. So log base 5 of 1/125 is -3. Okay. All right, so now we're in uncharted territory. Log base 4 of 32. Okay. So 4 to the x power is 32. So I'm going to use my common sense over here just to show you. 4 to the first power is 4. 4 squared is 16. 4 to the third is 64. So I want to be somewhere between 2 and 3. So I'm not going to play the guessing game, but I just want to confirm with you that that's where we're thinking. Always think about reversing the exponential equation when we're given a logarithm. Okay? So we've got x is equal to log of 32 divided by the log of 4. So if I plug that into the calculator, log of 32, close the parentheses, divided by log of 4, I get 2.5. Just to confirm, 4 to the 2.5 power is 32. So I'm going to show it to you. So personally, I would write this as 2.5. But the textbook likes it as a fraction. Personally, it doesn't matter to me one way. But if you know a thing or two about fractions, you'll know that I can, if I write this 2.5, that would be 5/2. So 2.5 is equal to 5 halves. So if I take 4 to the 5 halves power, that's square rooting the 4 and then 5th power. So that's 2 to the 5th power, or 32. So it checks out. But if it confuses you, you can always write it as a decimal. That's fine by me. Okay? I'm not gonna get mad if you're on team decimal or team fraction. Okay? All right, so let's take a look at number 10. Log base 8 of 32. Same thing. 8 to the x power is 32. And I'm just going to do a little thought bubble activity over here. 8 to the first is 8. 8 squared is 64. I mean, come on. It's going to be between 1 and 2. So I'm going to pull out my magic wand and do the logarithm. So I do the log of 32 divided by the log of 8. And so I get log of 32 divided by the log of 8, which is 1.66666666666, just to show you. Log of 32 divided by log of 8 is 1.66666666666. So it's 1.6 repeating, or 1 2/3, and if you want to be fancy with that, 3 times 1 is 3 plus 2, or 5/3. So I'm okay with you guys writing it as 1.6 repeating. But remember, please indicate that there's a repeating decimal on the 6, okay? But if you just want to confirm 8 to the 5/3 power, that'd be the cube root of 8, then to the 5th power. The cube root of 8 is 2. Taking that to the 5th power, that would be 32, and we're back in business. Okay. All right, let's do 2 more, and then we'll do a fun activity, at least in my opinion, a fun activity involving what if the logarithm has no base? Okay, so in this case, log base 1/4 of 16. Well, that means that the entire fraction 1/4 is taken to the x power, and we get 16. Well, we know that there's a relationship between 4 and 16. 4 squared is 16, but we're not dealing with 4 squared. So luckily, we've got our good friend, the logarithm, to help us out. 1/4 to what power is 16? So we can take the log of the output divided by the log of the base. So if I plug in the log of log of 16 divided by, did I close it? Yeah, I did close the parentheses. Log of 1/4, close the parentheses. I get -2. And the reason why is because of the negative exponent rule, where if I have a denominator, that can flip to a numerator with a negative exponent. So 1/4 to the -2nd power becomes positive 16. Okay. All right, number 3. This one, you're going to round to the nearest 5 decimal places, and this is where it's going to shine. So we've got 3 to the x power is equal to 18. Well, I put this one on there just to make sure that you guys didn't put 6. After all, 3 to the 1st power is 3. 3 squared is 9. 3 to the 3rd is 27. 3 to the 4th is 81. You get the idea. 3 to the 6th is going to be way huge. So it's not going to be 6, but rather the log of 18 divided by the log of 3, and I'm going to pull that from the calculator. So in this case, I get a huge number. Well, I mean, it's 2 point something, but you get the idea. I get this long decimal that doesn't seem to have a repeating pattern, so I'm just going to go to the 5th place. So I get 2.63092. What's the next decimal place? A 9. So does that mean I round up the 2 or round down the 2? Yeah, I'm going to round up that 2.63092 to become 63093. So let me just plug that in. So x is approximately 2.63093. So I'm going to put a little squiggle because it's approximate 2.63093. And if you don't believe me, you can check your work on the side. 3 to the 2.63093 power. It's pretty darn close to 18. I just rounded up, so that's why there's a lot of decimal places right here. Look at all those zeros, and it's like 4, 8, 7, blah, 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 blah. But the more decimal places you use, the more accurate your solution is. I like 5. 5 is a good number because 3 is too little. Let me just try 3 to the 2.63 631. Yeah, even like 1,000th, as you can see with the real life application, that's a big difference. So I'd say 5. 5 is a good set of decimal places to round to. So anyway, I want to close with these problems. Okay. So first things first, I'm gonna hide the second column. So we're gonna do 13, 14, 15, and 16, and I want to gauge your guys' ability to understand. So in this case, there is no base, and that kind of confuses me because, well, I mean, I can do it on the calculator, but it's like, all right, well, I'm a little bit nervous if I don't know what I'm doing. So log of 10 is 1. Huh. Okay. So log of 10 is 1. Okay. All right. Log of 100. Well, I don't have a base, so I guess I just got to go with the calculator and just plug it in. Log of 100 is, well, 2. Well, that's exciting. It's 2. Well, let's see log of 1,000. I bet you it's going to be really, really complicated. Log of 1,000. It couldn't possibly be 3. It's 3. So log of 1,000 is 3. Okay, and finally for now, let's go to log of 10,000. So the log of 10,000, come on, give me a really, really complicated problem. Complicated output for these students, it's going to be 4. So it's simple. It's simple. What do you think is going on? What do you think is going on when we do log of 10 getting 1? Log of 100 being 2. Log of 1,000 being 3. And log of 10,000 being 4. Okay? And get that thought in your head, and hopefully we'll confirm your theory tomorrow. But for now, in case you said, some of you guys probably said you're counting the zeros. There's a single 0 in 10. There's 2 zeros in 100. There's 3 zeros in 1,000 and 4 zeros in 10,000. Haha! Let's see if you got what it takes over here. If I do log of 200. 2.301029. I'm going to round that up to an 03. Squiggly. So I'm going to dispute your theory right there because I'm just going to assume that you said count the zeros and you're wrong. So then log of 200 is going to be, log of, I meant to put that over here. Sorry about that. 2.30103. Sorry about that. I meant to put log of 200. Let's do log of 20 first. 1.30103. Because I'm rounding to the nearest 5 decimal places. Okay. Then log of 2,000. We're on to something, but just to be a little bit more of a variety, what if I change that to 30,000? So log of 2,000 will be 3.0103 approximately. And then for this one, let's just say I do log of 30,000. Let's just say I hope it's 4, but it's not going to be. So I get 4.477. I get 121, but I'm going to round it down to 12. So we're going to find out in the next video what your precious little magic wand trick log button does. And if you have a good idea that isn't counting the zeros, you're probably right. See you then.